Hey guys, here is a video to help you with how to integrate using e to the x. So in the other videos, we talked about, if you have a function e to the x, the derivative is e to the x. What about if we have to go backwards? What would be the integral for e to the x dx? Well, if the derivative of e to the x is e to the x, well then the antiderivative of e to the x should also be e to the x. The only catch is, since this is an integral and it's an indefinite integral, we do need to remember that there might be a plus c involved, okay? If this was a definite integral over a particular interval, well then the c's wouldn't matter because they would end up canceling out anyway. So let's do some examples and see how that works. The good news is the relationship is still basically the same as it was, the original concept, but sometimes you're going to be able to, have to deal with problems that look something like this. 5 e to the x. So this 5 is constant, kind of just coming along for the ride. You almost could think of it as really just having the 5 out in front if you want, but you don't need to. You can just kind of leave it attached if you'd like and focus on the e to the x part. Well, the antiderivative of e to the x is e to the x. The 5 is coming along for the ride, so this would be 5 e to the x plus c. There's no reverse product rule or anything needed here simply because the 5 is constant. For example, old school, what if this was the problem? Right? So again, just like before, you'd ask yourself, well, what would you need to start with to end with, something like cosine? Well, you need to start with sine x. What about the 5? Well, if you start with 5 sine x instead of just sine x, you'll end up with 5 cosine x as your derivative. Okay? So the antiderivative is the same concept here as it was back here. When you're dealing with a constant in front is what I was trying to say. Okay, if you're ever not sure, look at what you came up with, take the derivative, and see if you get right back to where you started. All right, what if we kick it up a notch? What if instead of 5 e to the x, we did e to the 5x? Well, here it does get a little bit more complicated. Unfortunately, our rule is really just for e to the x. So this is e to some other thing that's not just x. Well, hopefully you remember that we do have a way to deal with those things as long as you remember our u substitution technique. If we let u equal the part that's causing the trouble, the thing, if you will, then we can take the derivative of that, which would be 5 dx, and say, all right, I could divide both sides by 5, and I have a way to substitute for dx. I have a way to substitute for 5x. And all you have to do is do your substitutions all the way through. If u is 5x, this part becomes u, that's e to the u, and dx becomes 1/5 du. So 1/5 du. And I do typically like to put the constants on the outside so you don't get as confused. But you don't have to. You could easily just keep it inside if you'd like. It doesn't make a difference. So all we did here, we did an old-fashioned u substitution problem, similar to if we had cosine of 5x. It would have been the same looking type strategy. And of course, the antiderivative of e to the u is e to the u. The 1/5 is coming along for the ride. Don't forget the plus c since it's indefinite. And u was 5x, so we're going to go ahead and plug that back in to get our final answer. And this would be your general antiderivative for e to the 5x. Again, you could take the derivative of this just to be sure. 1/5 e to the 5x, the derivative would be 1/5 e to the 5x times 5 because of the chain rule, and the 5 and the 1/5 would make 1, and you'd be right back to where you started. Okay, so if you need a little review of u substitution, there's plenty of videos for that that I've uploaded. You can check those out. Of course, if you just need general help, just ask. But let's do one more. Some of the feedback, people wanted just more examples. So let's do another one. And then I'll show you real quick also what happens if you have actual limits. So here's one. Let's throw a little trig in there. So what if it was cosine x e to the sine x dx, something like that? Looks pretty complicated. If it was just cosine, would be fine. If it was just e to the x, would be fine. But all these pieces together make it more complicated. So I'm going to focus on the thing that's causing the most trouble. This is causing trouble for sure, but I think the fact that our power for e is something other than just x is causing even more trouble. So I'm going to let u equal sine x. So du is cosine x dx Well, how convenient. This cosine x dx we have. That entire piece right here, this cosine x dx is right here. That'll become du. E to the sine x will become e to the u. And if I do this right, I believe that's how this will substitute. Watch again. Cosine x dx becomes du. So these two pieces of the puzzle here become du. So that's all set. E to the sine x, if u is sine x, becomes e to the u. That's all set. That antiderivative is just e to the u plus c, where u was sine x. So my final answer is here. If I wanted to check it, I would take the derivative of this, would be e to the sine x times the derivative of sine, which is cosine, which is exactly what we started with. That's it. So a lot of times u substitution does come into play for these. If you ever have something other than just e, I would look there first as your for your u sub. Now, just real quick to go back, let's just use one we already did. Let's just say for this example here, let's do it for for this one. What if instead of it being an indefinite integral, what if we did e to the 5x dx from say 0 to 1? Okay, so we would still do this whole process. The only thing that changes is instead of actually going from 0 to 1, don't forget these are x values. We need to make them u values. So if x is 0, u is 0. If x is 1, u is 5. So we would actually be plugging in 0 and 5 to get our values. We wouldn't need the plus c. Okay, so I'll do it here. I'll do this. I'll do it right underneath. So this turned into 1/5 from 0 to 5 of e to the u du. So instead of needing to do the general antiderivative, I would do the antiderivative evaluated from 0 to 5. Okay, I wouldn't need the plus c in this example. So this would become 1/5 e to the 5th minus 1/5 e to the 0. Excuse me. A lot of times people will mess up here because they just assume something raised to the 0 power is 0, but this is actually a 1. Anything raised to the 0 power here is going to be 1. So this is 1/5 e to the 5th minus 1/5. And you could leave it there. You might see it where they factor out the 1/5, but in this example, I think it's just as good both ways. All right, so that's how you would do one if it was a definite integral. The main idea, again, is, going back to the beginning, the derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. Just deal with a plus c if it's indefinite, or plug in the values if it's definite. And then more often than not, you're probably going to need to use u sub for a lot of these. All right, so hopefully that'll get you started. If you need anything else, be sure and let us know, and hopefully we'll see you soon.